As a science nerd, I love seeing science in the world around me. Cancer and black holes are awesome, but I also love seeing science in everyday life. Take the breakfast table, for example. Have you ever noticed that when you finish your cereal, the leftover Cheerios in the bowl either clump together or float around the edges? This phenomenon, known as the Cheerios Effect, is actually based off of some really interesting chemistry and physics. When we put an object in a fluid, a buoyancy force acts. This is the upward force exerted by a fluid on an immersed object, opposing the downward force of gravity. This is because the fluid below the object exerts a greater pressure on the object than the air above it. If an object is less dense than the liquid that it's in, then it floats. As we can see here. The Cheerios are less dense than the milk they are immersed in, so the buoyancy force holds the cereal at the surface of the liquid. We notice that where the milk meets the edge of the bowl, there's a slight curve, or meniscus. This is caused by surface tension. You see, milk consists of 90% water, which is a polar molecule. In water, the difference in electronegativity, which is a tendency for an atom to attract shared electrons, between the oxygen and the hydrogen is 1.22. This means that the molecule's electrons spend more time near the oxygen than the two hydrogens. This gives the oxygen a slightly negative charge, and the hydrogens a slightly positive charge. When multiple water molecules are together, the positive hydrogens of one molecule are attracted to the negative oxygen of another, creating strong hydrogen bonds between them. This means that water is attracted to itself, creating surface tension. This is what causes the meniscus that we observe around the edges of the bowl and around the edges of the cereal. When a buoyant Cheerio approaches the meniscus of another Cheerio, it will ride up that other Cheerio's meniscus, and then they will clump together. The same goes for when a Cheerio approaches the meniscus at the edge of the bowl. The Cheerio rides up the meniscus and then stays touching that edge. But what does this look like for other objects? Take these paper clips, for example. They float not because they're buoyant, but because of surface tension. The water bends down around the paperclip, but the attraction between the water molecules is enough to keep the paperclip on the surface. This, instead of creating a meniscus, creates a sinkhole that can suck objects into it when they get close enough. But the Cheerios effect has more applications than just breakfast. In nature, we see many insects using the Cheerios effect to their advantage when exiting water, such as pond strikers and water trekkers. Right now, scientists are researching the possibility of using surface tension to induce the self-assembly of small-scale structures. Turns out that the breakfast table isn't so boring after all.